Hello world, it's Rational Pi. And did you know that the wonderful thing about Tigers is that Tigers are wonderful things? Well, I'm sure you have. I'm sure you've heard that before. And the reason we bring that up today is because for many kids, that's the first time they're going to get the concept of recursion. And what recursion is, in a programming sense, it's where a function will call itself over and over again until a certain condition is met. What we're going to be utilizing recursion for in this series is going to be what's called a Fibonacci sequence. The Fibonacci sequence is a sequence of numbers where the third number forward is going to be determined by adding the previous two numbers together. So for example, the first two numbers are always 0 and 1, then the third number is going to be 1 plus 0 is 1, and then the fourth number is 2, then 3, then 5, and 8, and so on and so forth. So what we're going to do is we're going to produce the Fibonacci sequence using C++, and then in our second series, we're going to take the sequence that we produce and we're going to graph it using MATLAB. So we're going to go ahead and jump right into the logic. This is going to be more of a traditional Let's Code idea that I've been putting together, where we're going to have the logic pre-made so that we can create this first video, and in the second video we're going to go ahead and live code and see how that works for us. So this is a little bit more complicated, obviously, than our Hello World series. So let's go ahead and step right through the logic. So we don't want to just produce an arbitrary number of values for the Fibonacci sequence. We're going to go ahead and ask the user that's running our code how many values they want to find. It has to be greater than 0, obviously. You can have negative numbers in a sequence. And since 0 and 1 are always going to be the first two numbers of the sequence, we're going to go ahead and assume those and print those automatically. Then we're going to create the Fibonacci sequence with its function itself, and we're going to start it with n-2, and the reason we're doing n-2 is because we already know the first two numbers of the sequence, so we don't need to keep, so if they ask for 5 values, we only need to find 3 more values. And we're going to go ahead and create static values, and static means they will not change during the course of the program. First value, second value, and new value. That way we know that the first value that needs to be added, the second value that needs to be added, which are going to be obviously first 0 and 1, and the new value is going to be the newest number in the sequence. So, and then we're going to create a loop where if the number that was provided by the user is still greater than 0, and every time that we call the Fibonacci sequence, it's going to decrease the number of n by 1. So we're already starting, for example, if a user puts in 5, we're starting with 3 because it was n-2. So n will obviously be greater than 0. Since that's true, we're going to find the new value as the sum of the first value and second value. And then we're going to shift the numbers to where the first value is now equal to the second value. The second value is now equal to the new value so that we can set up the next number in the series. And then we're going to print the result, and we're going to loop, and then we're going to call the Fibonacci sequence again, but this time with n-1, so then we'll be at 2 if we're keeping with the 5 example, and then it'll loop back around and it's still equal or greater than 0, and it'll keep doing it again, and then once we get to the point where n is equal to 0, then we'll end the program. So let's go ahead and take a look at the pseudocode, and we're going to go ahead and write this live as well. So in our main function, so we're just going to call it main, we're going to ask the user how many numbers in sequence they request. Then the only other thing we need to do in our main sequence is call the Fibonacci function, and we're going to call it with n-2. Then in our Fibonacci sequence, we're going to print 0 and as first value, set first value equal to 0, print 1 as second value, and then we're going to set second value equal to 1. And then we're going to start the if statement. So if n is greater than 0, then we're going to have the new value is going to equal first value plus second value. And then we got to shift all the numbers so that the next time around we will have the new versions of the numbers. So that means first value will now equal to second value, and second value is now going to equal new value. And then what we're going to do, we're going to again call the Fibonacci sequence, but this time with n minus 1. So then end if, return 0 to end the Fibonacci, and then we're going to end Fibonacci. So let's go ahead and step through this one step at a time. Let's say the user asks for n equals 7. So then we'll start out with n equals 7. We're going to call Fibonacci with the original value of 7 minus 2, which is 5. So it's going to call the Fibonacci sequence. So then our first value is going to be set as 0. Second value is going to equal to 1, and then we're going to start the loop. So n obviously is greater than 0 because n is 7 currently, because we're stepping through right now. And so our new value the first time around is going to equal 1 plus 0, which is going to equal to 1. Fantastic. So that's going to be the third value of the Fibonacci sequence. So now we change the first and second value. So first value is now going to equal 1. Second value is now going to equal 1, because that's what the new value is. And then we're going to call Fibonacci of n minus 1, and since n is currently 5, as what was brought in from Fibonacci, is now going to be 4. Okay, so let's go through it one more time. So first value and second value are not going to change unless explicitly told to do so. So it's going to stay as 1 and 1 even though it says 0 and 1 whenever we implement the code. So n is still greater than 0 because right now it's 4. So our new value is going to equal 1 plus 1, which is now going to be 2. So now our first value is now going to change to 1 because that's what second value was. Our second value is now going to equal 2 because that's what new value is. And then again we're going to call Fibonacci with n minus 1, which is now going to be 3. And so it's now going to keep doing the same thing. So now n is still greater than 0. So again, new value is going to be 1 plus 2, which is now equal to 3. First value now becomes 2. Second value now it becomes 3. And let's call Fibonacci again, this time with 2. And it's going to keep going and keep going. Eventually, what this is going to calculate, since the user is asking for 7 values, it's going to be 0 as the first value, 1, 1, 2, because 1 and 1 is 2, 3, 1 and 2 is 3, 5, and 8. That should be what the code is going to output. So whenever we say that we're going to utilize this in MATLAB, what we're going to want to do is we're going to want to format the output and produce it into a text file so that MATLAB can read that text file in and utilize that data. Once we get to the series with MATLAB, we'll go back and show you how to save a set of data into a text file, and then we'll show you how we want to properly format it so that we can utilize it correctly and get the results that we're looking for. Eventually what we're going to do is we're going to produce what's called the Fibonacci spiral, and that is where the first value is going to be 0, 0, and then we're going to start it along the x-axis. So it's going to be 0, 0, and then the next one is going to be on the y-axis going upwards, so that's going to be 0 in the x direction, 1 in the y direction, and then it's going to loop around, so it'll be 0, 1, 1, 2, 3, 5, 8, and so on and so forth. So it makes a really neat looking spiral, and if any of you have ever heard of the golden ratio and the golden spiral, that's actually what it produces. Because if you create boxes underneath the spiral, the area of the boxes is actually equal to the area of the values of the Fibonacci sequence. And we'll be getting into that a lot more as the series progresses. The next video is going to be about the actual implementing of the code of this logic. And I hope you guys enjoyed this. If you have any questions or comments, please comment below. A like and subscribe is always appreciated. And we will see you next time.